Welcome back, Focus Learners. I am absolutely thrilled to have you here for another explainer. Today, we're looking at something truly fascinating, something that bridges the gap between hard science and human emotion. We are unpacking a newly published paper titled From Understanding to Resonance, a case study of quantum music and embodied science communication. This incredible research was conducted by Kenji Noda, Akira Koga, Stefan Heusler, and Koji Hashimoto. If you've ever felt totally intimidated by complex science, or, wondered if there's a better way to learn than just staring blankly at a textbook, well, this explainer is going to completely change how you view science education.
Okay, let's dive into this. Here is the million-dollar question. How do you actually engage people with science that feels completely distant and, frankly, inaccessible? Think about fields like quantum physics for a second. For most of the public, it's this entirely abstract realm, packed with equations and concepts that just completely defy our everyday logic. It can feel so out of reach. When we try to communicate these highly abstract fields, we almost always run into a massive roadblock. How do we bring the everyday person into a world that feels light years away from their lived reality?
Historically, our approach has been what researchers call explanation-centered communication, and honestly, it often hits a brick wall. Why is that? Well, because it relies entirely on a conceptual, top-down understanding. It's a lot of long lectures, dense facts, and overwhelming terminology. When you rely solely on explanation, you're essentially asking the audience to immediately grasp complex technical jargon right out of the gate. And the result? Audiences are left feeling alienated, intimidated, and just totally disconnected from the actual magic of the subject matter. It simply doesn't work for everyone.
But the authors of this paper decided to test a radically different approach. And they didn't just test it in a small lab, they did it on a massive scale. Imagine over 4,000 real people participating in a series of events specifically designed to completely bypass that traditional wall of jargon. They stepped into an environment that tested a totally new paradigm of science communication. No whiteboards, no pop quizzes, just a completely fresh way of looking at things.
And this brilliantly illustrates what they actually did. To reach those 4,000-plus people during the International Year of Quantum Science and Technology, two major initiatives were launched: Quantum Fest in Japan and Quantum 100 in Germany. But these definitely weren't your typical dusty science fairs. Instead of lectures, these events utilized immersive artistic experiences. We're talking live music, stunning visual art, and embodied participation, meaning the audience physically engaged with the space around them. The organizers essentially used art and physical presence to create brand new alternative entry points into the incredibly daunting world of quantum physics.
So, to truly understand if this artistic approach actually worked, the researchers obviously needed concrete data. They analyzed the impact through a really clear three-step methodology. Step 1, gathering quantitative and qualitative data using post-event surveys. Step 2, collecting direct participant comments to capture that immediate, raw emotional response. And Step 3, conducting in-depth stakeholder interviews. They weren't just asking people, hey, did you learn a quantum equation today? They were measuring the human experience of the event itself.
The data they collected led to a massive breakthrough. The findings revealed that this immersive, artistic approach creates something the authors call resonance. Instead of just passive understanding, where you're just absorbing facts, the participants experience three distinct dimensions of this resonance. And this is where the explainer gets incredibly exciting, because this framework of resonance completely reimagines the entire goal of science communication. Let's break down exactly what these three dimensions actually are.
Now, what's really interesting about this slide is the very first dimension: sensory immersion. When you use visual art and music, something fascinating happens in the human brain. The psychological barriers, that nagging feeling of, I'm just not smart enough to understand physics, they are significantly reduced. The intimidating defensive walls simply melt away. The sensory experience of a beautiful light show or a really compelling musical rhythm acts as a bridge. It invites the audience in, completely replacing fear and intimidation with wonder and curiosity.
Moving right along, the second dimension is collective embodied meaning-making. Okay, sure, it's a bit of a mouthful, but the concept itself is beautiful. It basically means that audiences aren't just sitting alone reading a textbook. They are interpreting and experiencing these abstract scientific concepts together in a shared physical space. By moving through an art installation or experiencing a live concert as a crowd, the audience turns abstract science into a shared physical reality. It makes the learning process a communal bodily experience, rather than an isolated, purely mental one.
Finally, we reached the third dimension, emerging transformative engagement. Because the audience was hooked by the sensory immersion and they shared a collective physical experience, it sparked something really profound. The data showed the development of a deep, lasting emotional and sensory connection to the scientific material. Participants weren't just memorizing facts to go past the test, their fundamental interest and attitude toward quantum physics were transformed entirely. It created this lasting hunger to engage with the science long after the event was over.
Let's actually put these two paradigms side by side to really see the difference here. On one side, we've got explanation-centered communication, which relies heavily on conceptual understanding and raw facts. On the flip side, we have resonance-driven approaches, focusing on emotional, sensory, and embodied connections. Now, what the authors make crystal clear is that resonance does not replace explanation. We still need the facts, absolutely. Rather, resonance acts as a powerful complement. By triggering the emotional and sensory pathways first, resonance actually paves the way for much better conceptual understanding later on. It's like a 1-2 punch.
So the crucial point is this. Audiences can form meaningful relationships with science before, alongside, or even beyond conceptual understanding. You absolutely don't have to perfectly understand the intense math behind quantum entanglement to feel deeply connected to the beauty of the quantum world. This is a monumental paradigm shift for how we can educate and inspire the public. We can invite people into the house of science right through the front door of art and emotion. I want to leave you with this final provocative thought. Can we build a meaningful relationship with science before we even fully understand it? Well, this research proves that yes, we absolutely can. By embracing music, art, and shared physical spaces, we unlock an entirely new way to inspire the next generation of focused learners. Keep this in mind the next time you are trying to learn or teach something incredibly difficult. Sometimes you just need to feel the resonance first. Thank you so much for joining me for this explainer, and as always, keep exploring.